clearances around electrical equipment. Let's go directly, my friends, into NEC code book. I know I highlighted it. I'm going to throw it one last time, and I'm going to go to page, that wasn't page 38, so it shouldn't be far away from here. Page 38. Electrical equipment. There you go. If you guys have not highlighted this one, please, that's where we're going to spend the time talking, a little bit of time talking about clearances around electrical equipment. So I'm going to go mark it with a highlighter. So this is the table plus all the notes. So if you guys, this is probably one of the most important table that you're going to take with you, Chris, when you talk to the architects. Why should they give you that 10 by 10 room for your electrical equipment? This is referenced more than anything else when we interface with the architects. Guys, the architects always see us as infrastructure that they need to hide. The infrastructure should be there to support you, but not seen and occupy any space. So they always keep squeezing us in the electrical closets and electrical rooms. They don't want to give you enough real estate because the real estate is very expensive, and they want to give it to somebody who sells merchandise or put offices for it so it can be productive space instead of dead space. This is, again, I can't emphasize, take this one. Every time they don't allow you to get the space that you want, you're going to be referencing this table, working space around electrical equipment. I can't. This is the law. What you're looking at here in the state of Minnesota right now is the law, because we adopted NEC Code Book 2011, August 8th. It becomes a law of the land, electrical law of the land in the state of Minnesota. So if you go to the architect and say, I can't violate the law, well, I hope there's your chances of winning other than, well, I think it's a good design. You know what I mean? Right? I think it's a good design. A lot of architects are very aware of this, guys. They're smart too. They've been dealing with it for years. So when you reference it, your chances of getting the space that you want is much better. So highlight this one, the condition. That's what I want to show. Then we're going to go directly into our space. Here's the space that we need to do. I'm grabbing this one. There you go. I know where my numbers. Okay. Back up. Okay. So I want you guys, if it's electrical equipment, do I have my plugged in here? Okay. Yeah, good. So here's all your electrical equipment, and this is the clearances. What we do, Chris, when we design electrical system in a building, at least at LB we did, we always, if this is my electrical, these are all our electrical equipment, we always shade an area, show an area like this, right in the front of the equipment to the width of the equipment, and we say this base, let's just say 3 feet. And we actually draw this base in CAD, we used to do in CAD, right in the front of the equipment so the architects know that this is a dedicated space and nothing should get into this space. So the working space for Ashley and all the electrical professionals, guys, to work on the electrical equipment, energized. So the step that we went, as I said at LB, is we draw a rectangle in the front of the equipment. I'm not asking you to do that. Our panels, Chris, we didn't draw anything. When we did it, you're going to find a lot of architects, engineering firms that draw a space in the front of the equipment to indicate that this is almost part, this space is part of the equipment. Don't mess with it. So if the architect is coming to move this wall one way or another, this space should be dedicated for you. When you get into, so this is the working space. To work on electrical equipment energized, on any of these electrical equipment energized, you're going to find the rules that we did in a second here. We'll go over the rules in a second for each one of them. Let's just go directly into rule number one. Rule number one, guys, if you have a panel like this, Ashley, the door have to open at least 90 degrees. Can't open more than that, but at least 90 degrees. So you should be able to at least 90 degrees open the door of that panel, which means I can't go put a wall right here or something. At least 90 degrees. So that's opening the wall. Questions about that? Opening any wall, any door, opening the door of a panel at least 90 degrees, at least, or more. Can you guys see that? 90 degrees or more. So moving into the second one, working space. A couple of things, housekeeping, guys. Working space, keep clear, do not use as a storage. So This one right now is violation of the code. Now moving this one this way, we're not violating the code. But I always, this is exaggeration, guys. If you put, what they don't want you to do, see that bookshelves there? They don't want you to put the bookshelves right in here. That's violation of the space, the working space for the equipment. But anything movable, you're not supposed to do storage. If actually the contractor walks in and if the inspector see this one here, he will ask you to remove it. Because that space is dedicated for Chad to work on the electrical equipment safely. So, use your judgment. If you guys, when we tour these data centers, you're going to see how clean they are. All the switch gears, nothing, no junk in front of them. And other places I've been there where you can't get to the panel. So no, this by code, you cannot, you can't use it as storage. You have to keep it clear of all obstacles. Okay, so moving on. Measurement, it doesn't bother for us, guys. We always measure the 3 feet dead front from right here, the cover. 3 feet in. The electrical industry is a big industry, guys. If this panel is open, can I have a panel that's open? Yeah, in certain applications, in a vault. If its bus is open, no cover on it. You can. They have it in vaults. Then you measure from the hot bars. There is no panel, nothing enclosed it. For you guys, probably 99% of you will work in panels that has a cover, so you measure from the cover. That's what they're trying to do here. If you have a cover, you measure from the cover. Okay, working space, the width. The width of the working space actually is always 30 feet or the width of the equipment, whichever is bigger. I have a 20-foot switch gear. The width of the working space must be 20 feet. If I have a 20 inches panel, width panel, then I have 30. Does that make sense? So minimum is 30, or the width of the equipment, minimum is 30. Minimum is 30, the width of the equipment. If I have a panel that goes all the way up to here, and from here to here is 15 feet, what do you think the space in the front of it, the working space is going to be? It's going to go all the way to 15 feet. The width of the equipment or 30 inches, whichever is bigger, I guess.
Not 15 feet back.
No, 50 width. Thank you. Yeah. And how deep the working space? You're gonna, let's just say from 3 to 4, 4.5, depending on the voltage. We'll talk about how deep. Yeah. And how high. Any question, guys, about this? So the width. So moving into the width of your equipment, minimum width of the equipment, or the height. Now we talk about the height. We talked about the height. This is very interesting. How high? So I have the working space. I know the width of the equipment to 30 inches. But how high can I go? Look at this, 30 inches or the height of the equipment. So if I have a switch gear that goes all the way to 92 inches, right? That's going to go all the way up to 92 inches. How much is 6.5? How many inches? 6.5. 80 inches. So if you have 92 inch switch gear, you're going to go to 92 switch gears. What that means, guys, is you can't bring a pipe coming right in here. Actually, right? You bring a pipe right in here into the working space, a duct right into the working space. You can't do that. You know, and you put your duct right here. Let's just say at 6 feet. 6 feet, right? That's inside the working space. Just mechanical duct. This has nothing to do with electrical. Just mechanical duct. Now, what do I do to mitigate this? I need to put all of my mechanical equipment above this space. So that's above that working space, which is 5.5 or the height of the equipment. So we know the width, right? 3 inches, 30 inches, or the width of the equipment, 5.5 or the height of the equipment. Now let's talk about the depth. The depth of the equipment. These pictures are really nice, guys. Okay, access to the electrical equipment. I don't think this is this for large equipment? Okay, let me go to the working. I'll get back to the working space, guys, is to allow the equipment, the people to work around it. Okay, let's get back to this one. Okay, let's go back. Why don't I have unobstructed? We'll talk about bigger equipment in a second here. Okay, the working space. I thought there's a nice pictures. I think they're coming. Let's get, I want to talk about there you go. This is the condition, how deep. How deep, this is, now we know 30 inches, 6.5, or the height of the equipment and the width of the equipment. How deep? How deep it depends on what's in front of you. If I have no live parts, here's my panel, no live parts. This is 150 volt to ground. You need 3 or less. So this will cover your 208 system, 120 volt, 240/120 volt, right, to ground. This then, you need a 3. So if your panel right here is any of these 2 panels, 2 systems, you are 3 feet, and in front of you, no live or grounded parts. In front of you is condition, what we call it condition 1. Any question guys about condition 1? Piece of cake, 3 inches. If you go to a system, this system, we talked about this one guys, 480/277 or 600/347 or something like this. These 2 systems, then you need to go also 3 feet. All of them are 3 feet. All of them are 3 feet. Any question guys about this? So for condition 1, if this is no live or no grounded, okay, 3 feet. The same rule guys for so we have, okay, so we have grounded. I think we have another picture for grounded. So any question about this? But you see the difference in the voltages? At this point, it's no difference. It's 3 feet minimum. Basically 3 feet minimum, whatever you do. If you go to the next one, look at this one. This is a grounded wall. Everybody knows what a non-grounded wall is. Sheetrock wall, wood, a grounded wall, block, concrete, metal, or anything. Okay, if you go to this, actually, it continues to be 3 inches. The only thing that changes, if your voltage is 480 or 600, then they add another half an inch. Half a foot. Does that make sense? They add another half a foot. Really, the only thing that changed right now is they add a half, minimum 3. They add half a foot if your system is bigger, big boy system. Okay? That's condition, that grounded wall. The last one, so we added the last one, guys, if you have energized equipment. You have energized equipment, look at this. Baby system, I call the baby system, 208 or 240. This system continues to be 3 feet, no matter what. 208, like our system, Chris, right now, regardless of what's in the front of the panel. What is it? Because we have 208, 120. You're going to end up with 3 feet no matter what. You jump into 480, 600 volt system, then what do you get? You get 4 feet. So that you range, guys, to summarize, for 208, 120, and 240, 123, no matter what. For 483, except if you have a hot equipment in front of each other, one of them is 480, it jumps 1 foot. If you have a grounded, you jump half a foot. That's it, summary of the whole depth. So your depth go from 3 feet to 4 feet. A lot of us in the engineering community, guys, you know what we do? We always put that 4 feet, no matter what, in the front of the equipment, even if it's 208. So you draw in front of the equipment at 2 feet. If this is my equipment right here, that's my equipment. What I do is I draw a 4 foot square in front of it. This is 4 feet. This one, let's just say this switch here was 6 feet. 6 feet, and I hash that area. And I say this is a sacred cow. This panel is 6 feet, and the depth is going to be 4 feet, regardless of the voltage, just to keep the space. Any question, guys? So because 4 covers the worst scenario. Any question about this? Can I have thumbs up, guys, to make sure? Now the panels that you have that you guys have with me, 208 and 120, you're going to make sure this is mainly for panels and anything that have an overcam protection device. Disconnect that have an overcam protection device too that need maintenance and fuses and so forth applies to them. Nick, you have a question? Your eye saying that you have a question? Oh no, we just. I like the pictures because it shows also the PE. Protective gear. Okay. All right. So this is just a couple of things about. Yeah, I'll get into. So we know what the depth, we know what the width, we know what the height. So let's summarize. 30 inches. The width of the equipment. The height is 6.5, or the height of the equipment, right? And the depth is 3 feet for almost everything except the voltage, the 480 and 600, 3.5 and 4 feet. So that's summarizing it. Color coding. This is very interesting. Color coding, guys, right here. Color coding for the two systems, 208, 120, and 480. These are very interesting. Brown, orange, yellow, and gray, and please, black, red, blue, and white. These are very interesting. They're not code. They're color-coded industry standard. So if you see a brown, orange, yellow, gray, most likely this system is 480, 277. If you black, red, blue, white, most likely this system is what? 208, 120. Though, a couple of things you have to understand. If you have two systems in your building, two systems, we don't have this. If we have two systems in our building, then that color code must be placed on every panel in your building. See that schedule here? I have to take it, label it right at the face of every system, of every panel that I have. Why? Because an electrician walk in, they need to understand the color code in that building. They have two. If you have two voltages, or if you have two systems. When I say if you have two systems, guys, if you have 208, 120, you don't need to label your panels with the color code of the system. If you have more than one system, like 208, 120, 480, 277, next project, then you have to have a label. This label, attach it directly to the face of every single panel in your building. Can I have thumbs up, Chad? We got it. Move on. Okay. This is a major thing. Number one. Number two, also, Ashley, if you have two systems like us at Dunwoody, we have multiple systems, 208, 120, 480, 277, then also the conductors have to be color-coded. You have to color code them. Can you see the phase by phase? Everybody can see how they're color coded by phase and by neutral. Can you see how every phase of every system is different? By phase and by system. By phase and by system. When I say by phase, phase A is different from phase B for the 208, from phase C, and from the neutral. Neutral is always different. That's no question asked. But also system by system. System A, phase A in system 1 is different color-wise than phase B in system 2. And by the way, this applies for branch circuits and feeders. Branch circuits and feeders. Can I get you guys to remember that? This is only required if you have two systems or more. If you have one system, Chris, I can't believe that they do that. If you have one system, you can use brown color for phase A, phase B, phase C, and white for the neutral, and that's legit. Nobody will do that. I mean, it will be stupid to do that. Why? Because the code, it's okay for the code, but nobody will do that. Why? It's a nightmare identifying phase A, B, and C. It's always good to color code them. So what they do most of the time, guys, if you don't want, you have two options: either color coded conductors. So if I'm going to do black, here's my black, and I have a red. And I have, what else do I have? I have a blue, and I have white. I don't have a white, so I'm going to put green for the white. Here's color-coded conductor. That's good enough. Color code them this way. And then the other colors, or for conductors larger than number 4, they start actually coloring. This is color-coded conductor. They start with the system, phase A, phase B, phase C, and a neutral, right? One color conductor. And guess what they do with the color? They identify them. This is phase with the tape. Oops. This is phase, let's just say this is phase A. This is phase A, phase B, and color on both sides, right? So I'm identifying it with tape at the end, wherever I have access to it, and then another phase C. Can you guys see that? If you walk in a place, and they're all black conductors, and they're color-coded at the end with a tape. They're taped to identify them. And this one will be white. They put a white on it. Oops, I don't have a white, so I'm going to put green. This is neutral, and I'm going to say this color is actually white, and white tape. So this is how you identify them, either by a tape, most likely will be a tape. A lot of companies that respect itself, they have color-coding insulation. Pricey on feeders, larger than number 4. As number 4 larger. I think number 6 and smaller, you have to be color coded. But number 4 or larger, they can be any color. Even look at that. Even actually the black can be neutral as long as you identify it with a white tape at the end that identify it as a neutral conductor. Any questions about this? This is very important. So please keep this in mind for feeders and branch circuits. And if you see, guys, right here, it gives you the feeder, and it gives you also here the branch circuits. The feeders and the branch. Color coding feeders and branch circuits a big deal. Big deal. My bud. Okay, so that's color coding. All right, so this is the most important thing about that one. Working space. Okay, the last thing, guys, I want to talk about in this chapter is what they call it large equipment. Large equipments. Okay, we talk about the height. Okay, if you have large equipment, dedicated equipment space, illumination. Okay, so sprinkler system outdoor. Okay, for large equipment, if you have large equipment, here's the definition. Let's go directly to the large equipment, baby. Here you go. Large equipment. Large equipment, guys, is how they define it. 1200 amp and 6 feet. I believe this is how they define it. 1200 amps or more and over 6 feet. I'm sorry, over 6 feet. 1200 amps and over 6 feet. If you have any piece of equipment, Ashley, that's 1200 amps or and, I emphasize the word and, because Chris always asks, well, is it or and, Chan? This is and more than 6 feet, then you apply the large equipment rule. You know what the large equipment rule tells you? The large equipment rule tells you have to have 2 entrances to that working space. 2 entrances to that working space. 2 entrances to that working space. So if you have a system like this, you have to have 2 entrances to the working space. Except, there's exception for it. Either you have 2 entrances to the working space. I want to draw a system like this here. So here's one entrance 1, and here's entrance 2, and here's my system here, my panel. And oh, by the way, my panel is 4,000 amp, and it's an 8 foot long. Okay? Then I have to have 2 entrances in either side of the room. Why? Because if there's a big ball of fire coming out of here, and you're in this area, they don't want you to get stuck in one corner of the room. They want you to be able to run, get the hell out of there. There's a big ball of fire. We're talking about major equipment here, guys. Very, very major equipment. Okay, so this is the rule. The rule is to have 2 entrances. There's one problem, though. What if this open to Hennepin Avenue here? You're downtown Minneapolis, and if the orientation of the room down here, if you want to put, is Hennepin Avenue. So you have 2 options. Either you have to have a ladder all the way to get the people out of that room, and yeah, the city of Minneapolis is going to allow you to do that, right? Right in the middle of downtown Minneapolis, put that steel ladder, like a fire escape ladder, or that's a lot of coordination. I'm not saying it doesn't have a lot of coordination. Or the option number 2, guys, is they have, if you can't have the 2 entrances, they give you 2 options. Option number 1 is to double the clearances. Double the clearances. So take this. If this was a 4,000 amp, and the length of it is 8 feet. 4,000 amp, 8 feet, and the voltage is 480/277. Make sense? Large equipment. If one of them in the room applies to all of them, okay? If you're in this situation, take this. Then they allow you to double the working space. You can double the working space. So in this case, if it's 4, it's going to be 8, and double the working space, it will be 8, and double the working space, it will be 8. You can double the working space and avoid having another entrance to the room. Every electrical room has to have an entrance. one entrance. If you have large equipments, you have to have two. Except if you double the working space is supposed to be 8 before here, multiplied by 2, give you an 8. Multiplied by 2, give you an 8. Then you don't have to, don't have to have two entrances. There's one requirement that this might not qualify here because of the distance of the entrance. Any question, guys, about double? Yes, sir. Oh, is it gonna die? Oh, thanks, boy. I'm glad one of us is awake here. Thanks. Any question, guys? So you have to have two entrances. But can I get you guys to understand what system are we talking about? 1200 amp, big major equipment. Do you remember, guys, what we talked about 1200 amp? 1200 amps are panel boards. You're getting into the end, actually the end of the panel boards. You're getting into almost switchboard design, big equipment. Okay, so that's for major equipment. I'm going to spare you the high voltage section. Or, here's another alternative for you. Or, the alternative is here's a room, and here's my one entrance, and you guys, one entrance coming to the room. The alternative, my friends, is you have unobstructed, they call it continuous unobstructed means of egress. Exactly how you, look at how we place our switch gear here. And if there's a big ball of fire coming out of here, and your friend Chad is working on the equipment here, so he can get the hell out of there, no one-way direction, unobstructed, straightforward. Then you don't have to have another entrance. The minute that Nick decided, he and the architects, to orient this switch gear here, you orient this switch gear here, now you have to have another entrance here. See what it goes by the orientation. If you want to get one entrance, make sure you put the door right opposite to the equipment. You get one entrance. You orient the equipment, you put it here, then you have to have another entrance, or double the distance, the clearing distance. Any question, guys, about the space in the front of the equipment? Okay, so they're obstructed. These are big deal, guys, when we, especially for us designers. Okay, here's what I talked about, guys, doubling the equipment distance. This is a 1200 amp or higher, and greater than 6 feet. Yeah, this is what I wanted to say. Working space double. So suppose this is a 480/277, actually. If you go to, and suppose that one was concrete. The wall here was concrete. If you guys go to concrete, that will give you 3.5, right? Grounded, 3.5, right? That will get you 3.5. So the clearance should be 3.5, but because we're going to double it times 2, that will give you what? 7 feet. So if the architects give you a 7 foot in front of the equipment, now that's how to negotiate with the architect. 7 feet in front of the equipment, then you can get away with one entrance. Except, do you guys see the edge here? This is also another requirement to apply this rule. Can you guys see the edge? The distance from here to the door, when your friend Chad is working on the equipment right here, and his eyes are on it, and his hair is coming up because there's big fire coming out of it, and he wants to get the heck out of there, right? He's getting fat and fluffy, he can't run fast, so you need that distance here to be 1D. What's 1D? 1D, this cannot be equal to 1D, which is 3.5. Where's the D is? The D is based on the clearances and the condition. So the switchgear cannot be placed further than 3.5 from the edge of the door. Does that make sense? So if I'm the switchgear here, from the edge of the door, I can't be placed more than 3.5 feet. Why? To allow Mr. Electrician to get the heck out of there upon the big explosion in the switchgear. That's the whole idea, safety. You might laugh at these rules, guys, but it saves lives, and it's the law. Why it's important? When you orient your switchgear as a project manager, Phil, you're going to go, you can lose a career over there. You put a 4,000 amp switchgear in a room, and you don't adhere to that rule, because now you got into the room. Now you're going to situate your switchgear inside the room, right? That's your electrician. You're going to put your platform for the switchgear. You're going to put the first stick here, and the first side, make sure it's no further than 3.5. If you have large equipment, please review this. If you have anything 1200 amp or higher and more than 6 feet, that's a switch gears. You have to pay a little bit good attention to this. Any question, guys? Can I have thumbs up? Make sure, Chad, we got that one. Okay. For large equipment. Okay. The working space, guys, that goes to the electrical equipment also. The large equipment must have a door like this, where if there's a ball of fire, you throw yourself in that door, in that bar, and you're out. Versus, what's the alternative? Versus a door like this. I don't want you to twist to run away. Twist, take time. You panic, big ball of fire, you throw yourself at that bar, or the door almost open. So that's a large equipment. Extra obstructed personnel door. That's for the large equipment. Okay, so we got that one. Okay, now we move into something called dedicated space. By the way, the working space also, yeah, that's it about the working space. We move into the dedicated space. The dedicated space, Ashley, is the space for the conduits. You guys remember what we talked about space for the conduit? In order for you to bring your conduit press right into the switch gear here, right? You want to bring your conduit almost always from the top or the bottom. Here's my conduit going this way. My conduit bringing power going this way, right? In order for you to bring your conduits and don't find a big 2 by 2 feet duct for the air handling unit right above your switch gear. So what are we going to do? By law, well, it is the law. They have nobody can enter this 10 feet. And by the way, this goes all the way 6 feet or height of structural ceiling. So if my equipment is right here, and I'm the equipment 6 feet above my head, or the structural ceiling height. If it's below 6 feet, you're not going to bust through the structural ceiling. But you can have a suspended ceiling right here in front of it. You can have a suspended ceiling. If I'm a switchgear, I can pull right through the suspended ceiling and go up and take my conduits up. But what they don't want you to do, guys, here, they don't want a mechanical contractor to come and put a big duct here, right? And right above the equipment, and good luck trying to find, good luck trying to move your equipment here, right? So if you see this, and there's a conflict between you and the mechanical, as a project manager conflict, you're going to take this rule, dedicated space for electric equipment. This is above and below the electric equipment, to the depth and the width of the electrical equipment. How deep is this space? If you take a cross-sectional area of this space here, if it looks like this, so you're going to take it to the width and the depth of the electric equipment. So suppose that was 4 feet, and so that was 8 foot. So 4 by 8 space above the switch gear, that's a sacred cow. Don't enter. Dedicated space, not working space, dedicated. Dedicated for the equipment, working for the people. Can I have thumbs up? We got it, Chad? Okay. So in this dedicated space, though, they allow you to have the area above the dedicated space shall be permitted to contain foreign protected, okay. Sprinkler system shall be permitted for dedicated space. If you have a sprinkler system, just dedicated for the switch gear, right above the switch gear, if there's fire on the switch gear, they don't open unless there's a fire. They allow you to get into a sprinkler system because that's protection for the fire protection. A suspended ceiling like this can enter this space, no problem. Suspended ceiling, sprinkler system, foreign systems. If you have right above the area, Chris, right here. So here's my dedicated space. Can I put a big fat duct here? Yes, as long as there's protection from leaking. They don't want you, guys, mechanical equipment are busy. Mechanical equipment rooms are extremely busy. They don't want you to put a water pipe right above the switch gear and that water pipe start leaking. It doesn't, not in the dedicated spaces, above the dedicated spaces. They try to avoid it unless you have some type of protection to protect leakage of this water pipe over my electric equipment. So the rule is avoid putting anything mechanical right above the equipment. If you have to, then you have to prove to the electrical inspector that what happened if there's a leakage. For example, if I'm to put a water pipe right there, I wouldn't put any couplings right at the top, because if you have a water pipe, not in the dedicated space, above, right here, And if you have a couplings here, that could leak. But if you have just a big conduit, right, the length of the equipment, highly unlikely is going to leak, right? But you might have to get into argument. So the rule is avoid putting anything even above that. So, okay, so that dedicated space. The space equal to the width, okay, above the space shall be permitted to contain further. Protection is installed to avoid damage to the electric equipment from condensation, leaks, or breaks in such foreign system. You have to provide some type of concentration. So the rule has always been as avoiding that area altogether. You know, so you don't, if you have a pipe and you need to direct your pipe, just move it away from that area altogether. And we are, and our cousins, so-called the mechanical engineers, we solve this problem. Can I have thumbs up that we got it, Chad? Yeah. Okay. So dedicated space and working space, big concept. A few other things left, guys, is light. In the mechanical equipment, in the electrical closets, and in the electrical equipment, you have to have a light. Anybody knows why we have to have a light? Hello, we're working on energized equipment, so you, for Pete's sake, you have to have a light. They want you to put a light, and when you put your light, they want you guys to kind of place your light close to the switch gear without entering the dedicated space or working space. You can't enter dedicated space. So if this is your mechanical equipment, this is switch gear right here, and my option is to put my lighting fixture here, only one lighting fixture right here, I would probably put my light fixture closer, right above the switch gear, not to enter the working space or dedicated space. Why? Because it wants to give you light so you can work on the equipment. So you have to have a light in the switch gear to illuminate the working space. In 2011, Chris, they came and they said you can't have an occupancy sensor here. Occupancy sensor. These lights in a closet, Phil, cannot be controlled by auto means only. You can have an occupancy sensor as long as you have to have a switch right here that override the occupancy sensor. So Nick is an electrician. Walk into the electrical room, turn the switch into manual, put the fixture in manual mode, work on the equipment. When you're done, put it in auto, meaning the occupancy sensor is controlling it, and get out. That was in 2011. So if you see an occupancy sensor, did you guys put occupancy sensor in the mechanical room? For example, if you have a mechanical room occupancy sensor, you got to be careful. You can, but you have to have a low voltage to override it.
It can be
No auto at all. Time, if it times out while I'm working, what's going to happen? They don't want to take the chance that you're working energized on these equipments, and either occupancy sensor or timer times the light off, and now you are faced with hot equipment, open panels, and the light is off.
So it should just be a standard on-off switch, but it gets power.
A low voltage switch would work perfect. You turn it on, or a high voltage switch like we did will work perfect. Turn it on, and when you lift, you turn it off. A low voltage will at night, if somebody in the mechanical room lifted off at night, they can sweep the whole system sweep off. I don't know how that will qualify.
Yeah, that's what I meant.
Yeah. You almost have to have a, no, I bet you some inspector will not even qualify because, you're in the middle of the night, you're working, sweep the whole light and you're dead. You almost have to have a manual override on it. Just the easiest way is put it in a snap switch. And that applies to closets, guys. If you have a closet that have electrical room and not ample amount of light coming from the hallway to it, you might have to put a light inside the closet if it's a smaller closet. Any question, guys, about this? So that's basically what this baby is all about. Okay, so we talked about all these. Any question? That's all what I have for you about this chapter. So I'm going to give you guys 5 minutes break, and then I'm going to go over what needed for the project.